Yo, this is an example of Weierstrass substitution. I don't know how many examples I'm going to make on this. This is like an introductory example right here. The integral of cosine x over 1 plus cosine of x dx. Now, this is advanced, to be honest. Now, this is a right triangle, despite how, fancy the triangle is. This is value is a 1, this is a t, this is the square root of 1 plus t squared. If you use Pythagorean theorem, you would know that. So, a squared plus b squared is c squared, yeah? But c squared is just the root of a squared plus b squared. Easy done. Cool. Now, this angle here is x over 2. Now, this guy called Weierstrass, German fella, he pretty much invented this, man. This guy's a genius, dude. So, I don't know how it works, why x over 2 works. It works, man. So, that's all you need to know. So, x over 2. The whole point of this is to convert the cosine of x's to a polynomial of t, right? So, we know the trig identity of cosine of 2x, yeah, is equal to cosine squared x minus sine squared x. But our angle is not x, it's x over 2. So what do? Well, you say that it's the angle cosine of 2x over 2. And what's that? Well, that's just cosine squared of x over 2 minus sine squared x over 2. Now, what do? Well, we look at our triangle here. Now that we have an equivalent angle, we can actually look at the triangle and say, right, well, what's cosine squared x over 2? Well, that's just 1, the adjacent, right? The adjacent's the 1 over the hypotenuse, right? So let's just write out what cosine of 2x over 2 is. That's equal to, like, what cosine of x is going to be. So what we're doing right now is we're trying to find out what cosine x is in terms of t. So that's 1 over square root of 1 plus t squared. Minus, because that's the adjacent over the hypotenuse, so it's all squared, because this term here is technically all squared. Like, if you were to write cosine squared of x, it's the same as cosine of x squared. Sorry, it's weird notation, I know. But anyway, minus, well, opposite over hypotenuse, which is just t over the square root of 1 plus t squared. And how do you solve that? Well, 1 squared is 1, and that's 1 over 1 plus t squared. And that's minus, well, t squared over, well, if you apply the squared value to the denominator, that's just 1 plus t squared as well. Which means that this is just 1 minus t squared over 1 plus t squared. Now, you're probably wondering, what do you do with the dx then? Because you can't integrate with variables of t with a differential of x. Well, here's the cool part. By the way, I'm going to split this video into 2 parts, as I've already noticed that this video is going on to 3 minutes. But this intuition and understanding is really important. So the idea is, I'm turning this cosine of x to the first power into a polynomial of t, and I found out that my cosine of x value is right here. This is cosine of x. Now, before I conclude the video, I'm going to show you how to get dx. Well, think about it. What is the tangent of x over 2? That's just equal to the opposite over the adjacent, which is t over 1. Now, what do? Well, let's solve for x. So, the arctangent of t is equal to x over 2, which means that the arctangent, x is equal to 2 times the arctangent of t. And then what do? You take the derivative. So dx dt is equal to, well, 2, and what's the derivative of arctangent? Well, that's just 2 over 1 plus t squared. That's the derivative of arctangent of x, but like this is in terms of t. So then dx is equal to 2 over 1 plus t squared dt. And that's literally it. And these are the substitutions you're going to make. So you've got dx here, we've got cosine x here, so we're ready to solve the integral. So in the next video, I'll solve the integral.